Good morning to all. I am M. Thanga, APCSE, PSR Engineering College, Sivagasi. Today I am going to handle a session on Transmission Control Protocol. Transmission Control Protocol is a protocol that is present in the fourth layer of the OSI model. It is most widely used in Internet today. TCP is a connection-oriented byte stream protocol. It guarantees the reliable in-order delivery of a stream of bytes. It is a full duplex protocol that each TCP connection supports a pair of byte streams, one flowing in each direction. It includes a flow control mechanism for each of these byte streams that allow the receiver to limit how much data the sender can transmit at a given time. Then next is the features of TCP. The first one is a process-to-process communication. TCP provides process-to-process communication using port numbers. The next is a connection-oriented. TCP is a connection-oriented protocol. A connection needs to be established for each pair of process. When a process at site A wants to send and receive data from another process at site B, the following three phases occur. First, the two TCPs establish a logical connection between them. Next, data are exchanged in both directions. At last, the connection is terminated. The next is a full duplex communication. TCP offers full duplex service where data can flow in both directions at the same time. Next is a flow control, and next congestion control, and last multiplexing and demultiplexing. TCP performs multiplexing at the center and demultiplexing at the receiver side. The next is a TCP packet format. Each TCP segment contains the header and the data. The segment consists of header of 20 to 60 bytes followed by data from the application program. The header is 20 bytes if there are no options and up to 60 bytes if it contains options. First is a source port and destination port. Port number of source and destination process are entered in this position. The next is a sequence number. Contains a sequence number, that is first byte of data segment. And next is a acknowledgement. Byte number of the segment. The receiver expects next. The next is a header length. Length of the TCP header as a 4 byte words. The next is a flags. TCP contains 6 control bits known as flag. First is a URG, that is urgent, contains the urgent data. Then next ACK, acknowledgement. Value of the acknowledgement field is valid. Then push. Sender has invoked the push operation. Then next reset. Receiver wants to abort the connection. Then next synchronize. Synchronize sequence number during connection establishment and at last finish. Used to terminate the TCP connection. The next is a advertised window. It defines receiver's window size and acts as a flow control. The next checksum. It is compared over TCP header, data and pseudo header containing IP fields. Then last URG pointer. Used when the segment contains urgent data. It defines a value that must be added to the sequence number. Then next, TCP connection management. A connection-oriented transport protocol establishes a logical path between source and destination. All of the segments belonging to a message are then sent over this logical path. In TCP, connection-oriented transmission requires 3 phases. First is a connection establishment, then next data transfer, and at last connection termination. Connection establishment. Connection establishment in TCP is a 3-way handshaking. First, client sends a synchronized segment to the server containing its initial sequence number. Then next, server responds with a segment that acknowledges client segment and specifies its initial sequence number. And last, client responds with a segment that acknowledges server sequence number. The next one is a data transfer. After connection is established, bidirectional data transfer can take place. The client and server send data and acknowledges in both directions. The data traveling in same direction as an acknowledgement are carried on the same segment. The acknowledgement is piggybacked with the data. And at last, connection termination. Connection termination or tear down can be done in following ways. Client sends a finish segment. Then the finish segment can include last chunk of data. Server responds with finish plus acknowledgement segment to inform its closing. Finally, client sends an acknowledgement segment.